Welcome back, boys and girls. This is Go Math, grade 4, lesson 3, multiply two-digit numbers. This is lesson 3.3, investigate area models and partial products. Right, this is lesson 3.3, area models and partial products. Our essential question is, how can you use area models and partial products to multiply two-digit numbers? Well, we're going to investigate. You need colored pencils. If you don't have them, please get them out. You need blue, green, orange, and purple. It says, how can you use a model to break apart factors and make them easier to multiply? Well, A, outline a rectangle on the grid to model 13 times 18. Break apart the model into smaller rectangles to show factors broken into tens and ones. Label and shade the smaller rectangles and use the color below. So you see what they did here. They went 13 times 18. They went 13 down and 18 across. I went here, 13 down and 18 across. Make sure that you do that, okay? Now it says find the product of each smaller rectangle, then find the sum of the partial products and record your answer. Well, they went 10 down, 10 across. 10 times 10 is 100. 8 times 10, 8 down, or I'm sorry, 8 across. 10 down, 8 times 10 is 80. 3 times 10, 3 down, 10 across, 30. 3 times 8, 24. 3 times 3 down, 8 across. Once you add all of them up, you get 234. So 13 times 18 is 234. Now what they're asking you to do is to do the same thing with 13 times 18, but use different numbers. And what they did was they used, I used 9 and 9 and 9 and 4. 9 plus 9 is 18. 9 plus 4 is 13. So 13 times 18. So 9 times 9 is 81. 9 times 9 is 81. 9 times 4 is 36. 9 times 4 is 36, and it adds up to 234. All right. Now it says, explain how you found the total number of squares in the whole model. Well, I broke apart the model into 4 smaller rectangles and found the product of each. I then added the products, and that's what I did. I broke this larger rectangle down into 4 smaller rectangles, and then I found the product. All right. Compare the two models and their products, and what can you conclude? Well, the products are the same. It still came out to be 234, no matter if I went 13 times 18, or I'm sorry, 13 times 18, no matter if I went 10 8 and 10 and 3, or if I went 9 and 9 and 9 and 4. It didn't matter. The products are the same, and this shows that you will get the same product no matter how you break apart the model. No matter how you break 18 down and 13 down, you're still going to get the same product. All right, 3. It says to find the product of 10 and 33. Which is the easier computation? 10 times 11 plus 10 times 11 plus 10 times 11, or 10 times 30 plus 10 times 3? Explain. Well, 10 times 30 plus 10 times 3, I can use the fact 1 times 3 and what I know about multiples with 10 and a pattern to find 10 times 30 plus 10 times 3. It's always easier to multiply numbers with multiples of 10, okay? It's always much easier to do that because you can use your basic fact, in this case 1 times 3, to figure out what 10 times 30 is. Remember, 1 times 3 is 3, add the 2 zeros, it's 300. All right, make the connection. You can draw a simple diagram to model and break apart factors to find a product. Find 15 times 24. All right, so 24 has to go across, 15 has to go down. Well, they already have 20, so we have to fill in 4. They already have 10, so we have to fill in 5. So 20 times 10 is 200. 10 times 4 is 40. 20 times 5 is 100. 4 times 5 is 20. So 2 times 2 tens, or 2 times 20, is 200. 10 times 4 ones, or 4 times 10 times 4, is 40. 5 times 3 tens, or 5 times 20, is 100. 5 times 4 ones, or 5 times 4, is 20. Now it says to add the products of the model. 200 plus 40 plus 100 plus 20 is 360. So 15 times 24 is 360. The model shows 4 parts. Each part represents a partial product, and the partial products are 200, 40, 100, and 20. Okay, boys and girls, now it is your turn to do pages 159 and 160, okay? Pause the video, do pages 159 and 160, and start it again, and we'll check your answers, okay? Boys and girls, here are the answers. I want you to look carefully to see if you got the answers right. If you did not get the answers correct, you need to pause the video and check to see what you did wrong. 16 times 19 is 304. 10 by 10, 9 times 10, 10 times 6, 9 times 6, add them to get 304, okay? Look at how we did this. I'm not going to go over it all with you. You need to look at it. All right. Now it says draw a model to represent the product of 14 times 16. I did 10 and 6. You could have went 12 and 4. It didn't matter. Okay. You could have put 12 and 2, because 10 and or 12 and 2 is 14. As long as your two numbers here added to 14 and your two numbers here added to 16. All right, the answer is 224. 23 times 25, I went 20 and 3 and 20 and 5. The answer is 575. Let's look at question number 6. It says, explain how modeling partial products can be used to find products of greater numbers. Well, you can use mental math to find partial products and then find the sum of the partial products. All right. Look at number 7. It says, Emma bought 16 packages of rolls for a party. There were 12 rolls in a package. After the party, there were 8 rolls left over. How many rolls were eaten? Explain. Well, there were 184. I multiplied 6 times 12. Okay. Hold on one second. I'm sorry, boys and girls, there was someone at the door. There were 184 rolls. I multiplied 16 times 12, 16 packages times 12 rolls in a package, to find that there are 192 total rolls. Then I subtracted 8 from 192 to find 184 rolls eaten in all. Okay. Does this make sense or not, or nonsense? Jamal and Kim use different ways to solve 12 times 15 using partial products. Whose answers make sense? Whose answer is nonsense? Well, Jamal says 10 times 5 and 10 times 2, or 10 plus 5 and 10 plus 2. 10 times 10 is 100. 10 times 5 is 50. 10 times 2 is 20. 5 times 2 is 10. All right. He says 100 plus 20 plus 10 equals 130. Is that correct? No, he didn't add that 50. So his answer is nonsense because only 3 partial products were added. 12 times 15 must be greater than 19 times 15, or 150. He forgot to add that 50 there. Let's look at Kim's work. She went 10 times 10 is 100, 10 times 5 is 50, 10 times 2 is 20, 5 times 2 is 10. She went 120 plus 60 is 180. Well, she went 100 plus 20 is 120. 50 plus 10 is 60 is 180. And this answer makes sense because the sum of the 2 pairs of partial products were added to find the product. The product. She just added these and these. That's all she did. All right. A, for the answer that is nonsense, write an answer that makes sense. Well, Jamel should have written 100 plus 50 plus 20 plus 10 equals 180. And it says, look at Kim's method. Can you think of another way Kim could have used the model to find the products? We'll explain. Well, Kim could find the sums of the partial products, 150, and the sum of the partial products, 20 and 10. Then she could add 150 plus 30 equals 180. Okay, so she could have done it that way. Number 9. Look at the model in 8B. All right, right here. It says, how would the partial products change if the product was 22 times 15? Explain why you think the products change. Well, the partial product, 150 would become 200 and 100. Those 2 products changed because the tens digit of 22 is double the tens digit of 12. Okay, boys and girls, it is your turn to do page 161 and 162 by yourself. When you're finished, take a snapshot, send it to me. I'll grade it, and anything that you did wrong, I'll send it back to you and let you correct it before I put it in the grade book. And this is the end of lesson 3.3. Don't forget to like this video and subscribe to my YouTube channel at Awesome Possum Classroom 451. If you would like these worksheets, email me at awesomepossumclassroom@gmail.com and I will send you the link. Have a great day, and I'll see you for our next lesson.